So in this lesson, we're going to learn what a rule is and how it relates to the graphs that we've seen so far. And we're also going to check if a point lies on a line. So hopefully by the end of this video, you'll be able to tick off the 2 success criteria. So last lesson, we looked at how to plot these coordinate points on a number plane like this. And today we're going to focus on straight lines, which simply is what happens when you put a line through your points that follow some sort of order. So these straight lines can be given a rule. This line that you see on your screen is called y equals x plus 1. And that's what we're going to focus on today. How did we get that rule? So first of all, what is a rule? A rule is an equation which describes the relationship between two or more variables. So our two variables here is x and y. They're the two things that can change. And this here on the left is an example of what our rule looks like. A linear relationship will result in a straight line graph. So just to keep it simple, a linear relationship is a straight line between x and y. So how does this make sense? How does this little rule here, y equals x plus 1, represent the graph that you see on your screen? Well, let's think about it. What happens when x equals 0? What's our coordinate point? Our coordinate point is when x equals 0, I'm going to use blue here, that's here. It hasn't gone left or right, but it has gone up 1. So when x equals 0, y equals 1. Now this rule up here, if I use that to explain how this comes about, I would be pretty much doing this. Let's substitute x equals 0, and what do I get? So when x equals 0, y equals 0 plus 1. And that gives me just 1. So my coordinate point is 0 and 1, which you can clearly see there on your graph. So let's summarize this with the table. So when x equals 0, y equals 1. What happens when x equals 1? When x equals 1, I'm going to use that rule, and I'm going to say 1 plus 1. Well, y should equal 2, right? And as you can see there on your graph, when x equals 1, y equals 2. So that's how we get 2. This rule here that you see at the top of your screen will pretty much continue on giving you the correct points until however long you want to go. But we're just going to stop at 4. So when x equals 2, y equals 3. When x equals 3, y equals 4. So pretty much, whatever the x value is, just add 1, and that will give you your y value. So here we're given 2 rules, and we're going to first work on the first one, and we're just going to complete the table. We're pretty much going to do a whole lot of substituting just to figure out what our y value equals. So here we have when x equals 0, what does y equal? Well, y equals, just substitute it in for x, and 3 times 0 is 0. Take away 1 is negative 1. And that's how we get negative 1 there. What about when x equals 1? Well, let's substitute 1 for x. 3 times 1, take away 1. Well, that is 3 times 1 is 3. Take away 1 is 2. That's how 2 gets in there. What about when x equals 2? Well, y equals 3 times 2, take away 1, which gives us 6, take away 5, 6 take away 1, which gives us 5. And that's how 5 gets in there, and we keep going, and that's how we get 8. Let's do this example here, and I'll only do the first one. So when x equals 0, what does y equal? Y equals 2 times 0 plus 5. 2 times 0 is 0, plus 5 is just 5. And so on. You need to keep substituting to complete the table. And from here, I'm going to rub all this out. You can then find your coordinate points for the graph. So, when x equals 0, y equals negative 1. So that's my first point. Let me continue to rub this out. When x equals 0, y equals negative 1. So this is my first point. When x equals 1, y equals 2. 2 and 5, and 3 and 8. These are my 4 dot points that I can put on my Cartesian plane. So let's put that all together here, and let's take a rule, construct a table, and draw the graph. So here we have our table, our x and y values, and whatever x values you choose is up to you. But at the end of the day, keep it close to 0 and make sure that they're going up by 1. So you can see that it starts at negative 2, goes to negative 1, 0, 1, 2. Don't just put random x numbers in there. And then all we need to do is figure out what the y values are. So when x equals 2, what does y equal? Well, y equals 2, substitute 2 in there, plus 2. And that gives me 4 plus 2, which gives me 6. When x equals 1, let's substitute x equals 1 and add 2. So that gives me 2 plus 2, which equals 4. And you keep following that. Don't forget to multiply your negative numbers correctly, and you should get a full set of table of values. And then you can plot them. So just like we did in the previous slide, we were able to find a series of coordinate points. So the first one, 2 and 6, there we go. 1 and 4, 0 and 2, negative 1 and 0, and negative 2 and negative 2. And this can keep going as down, as high, as left, as right, as long as you're following that same sort of pattern. And of course, to finish it off, put in your straight line. Now it's really important that if you draw your graph in your book, that you actually label the axes. So you've got your x-axis and your y-axis. Make sure you use a ruler to draw your straight line, otherwise it won't be straight. And this is pretty much all you need to do in terms of graphing from a rule. So here we've got a typical question. Decide if the points 1, 3 or negative 2, negative 4 lie on this line, which is called y equals 3x. Okay, so let's look at the first point, which is 1 and 3. What I'm going to do here is I'm just going to substitute my x and y value into the equation. So here we have x on the left, remember, and y on the right. Let's substitute x equals 1 into the equation. So if I do that, I get y equals 3 times 1, and y equals 3. So when x equals 1, y should equal 3. So you can see here that, yeah, I've got y equals 3 here, so yes, it does lie on the line. This point here, negative 2 and negative 4, what I'm going to do straight away, substitute my x value, which is negative 2, into the equation. So y equals 3x, y equals 3 times negative 2. And if this point lies on the line, y should equal negative 6. Quite clearly, this point here says we have y equals negative 4. So this does not lie on the line. This is an example of it does lie on the line, and this is an example of it does not. It's very important that you recognize the difference here. All we've really done for both of these situations is substitute the x value and hope that whatever we get here matches up with what our point tells us. Whatever we get here should match up with whatever our point tells us. And on the right of your screen, you can see that they don't match up. So that's why that point does not lie on the line.